Here's our Math 158 homework discussion from 8.2, rational exponents. And once again, I have my calculator handy. I don't think I'll need it for this section, but we can certainly use it. Evaluate each exponential. Number 11 in the textbook says 169 to the 1/2 power. Remember, the roots are on the bottom. So this is the square root of 169. And if we know our 13 times 13, we have that immediately. If we don't, we could go to our calculator and just hit the square root button with 169 and get 13. Okay, so that's not bad. Number 19. Number 19, this is a problem that we saw on the other video. Minus 27 to the 1/3 power. Again, the root's on the bottom. So this now is the cube root of 27, which we know is -3. You can do this a couple of ways. You can use the fractional power. Make sure you put parentheses here, -27 raised to the 1/3 power if you have a calculator. I don't think that's a calculator problem. Number 27. Okay. Number 27 has the opposite, negative 16 to the 5/2. Now remember, this is reminiscent of this problem that I said I give my high school kids every year when they start school. What is that? And the answer is -9, because according to the rules order of operations, you have to do this exponent first. So this really does mean the opposite of 9. Okay, so the same thing applies here. This is the opposite of 16 to the 5/2. And again, the roots are on the bottom. So this is a square root of 16 to the 5th. And you can put the 5th inside or outside. It's much easier to put it outside. The square root of 16 is 4, and 4 to the 5th. If I don't know that, I can just jump over here and put 4 raised to the 5th. Okay, so that is a 1024, but this does say the opposite of it. So don't forget to do that. The opposite of 4 to the 5th is the opposite of 1024. Okay. The good news is the calculator works order of operations exactly right. If I had the opposite of 4 raised to the 5th, it does give me the right answer. So most calculators are programmed correctly. New screen. Let's look at number 35. Number 35, we've got 125 over 27. Nice fraction there. And then the fractional power is -2/3. Okay, so the trick here was you can change this immediately to a +2/3 if you swap the places of the numerator and the denominator. So the 27 goes here, and the 125 goes here. That's an allowed thing to do. Flip the fraction upside down and remove the negative sign in front of the exponent. Okay, so now we have 27, and I'm going to write this as 2 separate problems. To the 2/3 divided by 125 to the 2/3. Again, the exponent will apply to each part of this fraction. Very similar to if you had 2/5 and we were cubing that, that's the same as 2 cubed divided by 5 cubed. Here the cube would have to go with each one. Okay, so now let's see what we've got. Remember, the roots are on the bottom. So this is the cube root of 27 squared divided by the cube root, roots are on the bottom, there they are, of 125 squared. Cube root of 27 is 3, and the cube root of 125 is 5. So this is 9 over 25. That's your answer. Okay. Number 45. Number 45. we've got 2m in parentheses now to the minus 3 halves. So what I'm going to do here, I don't have a fraction. I suppose I do if I consider this 2m over 1. I'm going to write this as 1 over 2m, right, raised to the positive 3 halves. I could do it that way, and that would work fine. So this is going to be 1 to the positive 3 halves divided by 2m parentheses to the positive 3 halves. And again, what I did was the same thing I did on the other problem. Remember, this is effectively a fraction, 2m over 1, and I put the numerator on bottom and the denominator on top, and then changed the exponent from negative to positive. Okay, well, 1 to any power is just 1. So the numerator here is just 1. And now I have to deal with 2m to the 3 halves. What am I supposed to make of that? Okay, so if we look at the, actually skipped problem number 39, but if we look at the directions here, it says write with radicals, assume that all variables represent positive real numbers. So I can write this now as a radical, 1 over the square root of 2m cubed. So that would work fine. 1 over the square root of 2m cubed. I can also write it this way, and I will look in the back of the book and see what the author claims is the simplest way. This is 1 over the square root of 2m cubed. Here I'm putting the cube on the bottom. So that's 1 over the square root of 2m times 2m times 2m. And because it's square roots, we're looking for pairs. I've got a pair of 2's, that would come out front. I've got a pair of m's, that would come out front. So if I pull those out in front of the radical sign, I've got 1 over 2m, and what's left is the square root of 2m. Now you may be a little concerned about, the square root of m squared is supposed to be the absolute value of m. But if you read the directions, it does say assume the variables are positive. So if I put the absolute value here, I can immediately take those away because I know that m is a positive number. So this is a good way to write the final answer. Let me pause this and see what the author has in the back for his solution. Okay, back again. The author in the back left it this way up here. So this was his answer. Any one of these would be correct. As long as you follow the directions, and the directions said write with radicals. So this is written as a radical. All this other stuff I did below here is perfectly valid, and it is, I guess, another way of writing the problem to make it a little bit simpler looking. Okay, let's back up to the one I skipped. That was problem number 39. Number 39, it just says write with radicals, 10 to the 1/2. The roots are on the bottom. This is the square root of 10, and that's all you have to do. They do not ask you to come up with an explanation. Okay, problem number 51. The directions say simplify. Number 51. And again, I'll copy the directions verbatim for test questions. Simplify by first converting to rational exponents. Assume all variables represent positive real numbers. So we have the square root of 2 to the 12th, which is 2 to the 12th to the 1/2 power. And then I'm going to use my properties of exponents. This is 2 raised to the 12 times 1/2. Remember, you would, whenever you're raising if we have x squared cubed, the rule was to multiply these. That's x to the 6th. And that's what I'm doing here. I'm multiplying the 12 times the 1/2. 12 times 1/2 is equal to 6. So I have 2 to the 6th, and that simplifies to 64. So if you know your powers of 2, great. If not, you can just jump in here, raise 2 to the 6th. Oops. 2 raised to the 6th. There. Okay, that's number 51. And again, I had to go through the step of changing it to fractional powers because that was part of the instructions. If I simply did the square root of 2 raised to the 12th, which is what the problem says, and I just write down 64, I have not done what they've asked me to do. They did say very explicitly in the instructions to rewrite using fractional power. So you have to go through this step before you get there. Okay, problem 59. 59, we've got the cube root of t to the 4th. Here they put the 4 underneath, divided by the 5th root of t to the 4th. T to the 4th. So let me write this as t to the 4/3 and t to the 4/5. Right? Remember, we're trying to get the roots on the bottom. So here's the root, and that has to go down here below the ground. And the same thing up here. This is the root, and that has to go below the ground here, like that. Okay, so now we have a t raised to a couple of powers. Let me just go back to something that we sort of remember. If we had x raised to the 5th power divided by x raised to the 2nd power, you know you're supposed to subtract here. This would be x to the 5 minus 2, x to the 3 power. So I have to do the same thing here. This is going to be t, and I'm going to have to take 4/3 and subtract 4/5. So yeah, you can use your calculator. If you want to do that on your calculator, you can. Hopefully you can deal with fractions without a calculator. 4/3 minus 4/5. Okay, it works out to be that decimal. And if I put it as a fraction, I get 8/15. So this is the same as t to the 8/15. Now again, let's go back to our directions. It says simplify. So I've done as much as I could there. This now becomes the 15th root of t to the 8th. And again, you can put the 8 out here if you like, or you can bring that 8. Let's see if I can do this. I can put the 8 out there, or I can bring the 8 and put it inside. It doesn't matter. You get the same answer. So flipping back at the back real quickly, for 59, they have the 8 on the inside. So they leave it this way. But it would be perfectly acceptable to put the 8 on the outside. Okay. Let's see. Next problem is problem 67. Number 67. And the directions say simplify each expression, write all answers with positive exponents, assume that you only have positive real numbers for variables. So we don't have to worry about absolute values on these. We have x to the 2/3 times x to the minus 1/4. And again, I'm just going to remind you, if you had x squared times x cubed, think about what you would do here. You would add the exponents up. So we're going to do the same thing here. We're going to add these exponents. This becomes x to the 2/3 plus a negative 1/4, or better yet, x to the 2/3 minus 1/4. And we should be able to do that reasonably quickly. You might remember my shortcut. I would say the denominator here is going to be 12, and then I would look and I would go, I've got 2 times 4, that's 8, and 3 times negative 1, that's negative 3. 8 minus 3 is 5. Okay, so I've got x to the 5/12. Write all answers with positive exponents. So I'm finished. If I wrote this as the 12th root of x to the 5th, it's not a wrong statement, but I haven't followed the directions. The directions said write with positive exponents. You want to stop here. Okay, problem number 73. Charging through these. 73, we've got x to the 2/3, and that's squared. So think about how again, think if you had a squared cubed, aren't you supposed to multiply? Okay, so we're going to be multiplying these together. And then on the bottom, we've got x squared, and that's raised to the 7/3. Okay, so the numerator, we've got x to the, let's see, 2/3 times 2 is just 4/3. And on the bottom, we've got 2 times 7/3, so that's 14/3. Okay, now we're at the stage where we can subtract exponents. Again, just sort of think about what you would do if you had a fraction a to the 10th divided by a to the 7th. You would subtract the exponents and get a to the 3rd. So we're going to do the same thing here. We're going to subtract the exponents. We've got x to the 4/3, take away 14/3. Well, I can do that in my head. That's common denominator. X to the negative 10/3. Okay, so far so good. Let's go back and look at the instructions. It does say write all answers with positive exponents. Okay, so now we're going to have to use our rule on negative exponents and shove this down 1 over. Right, you're going to take this and put it underneath x and change it to a positive 10/3. So that would be our final answer as written with positive exponents. And let's just double check. Okay, no problem. Okay, number 79. We're getting close to the end here, or at least to the end of my patience. 79. If I was a doctor, I would go broke. I would have no more patients. We have b to the minus 3/2 divided by c to the minus 5/3. That whole thing is raised to the 2nd power. And then once we figure out what that is, we have to multiply that. We have b to the minus 1/4 power, c to the minus 1/3 power, and that whole thing is raised to the minus 1. Okay, so let's do these things first. We're going to be multiplying negative 3/2 times 2, and that gives us b to the negative 3. And then we're going to do the same thing. We're going to multiply negative 5/3 times 2, and that would be c to the negative 10/3. Okay, so that's the first bit. And let's see what we've got on this next bit. I'm going to be multiplying the minus 1/4. Minus 1/4, I will multiply that times minus 1. So that gives me b to the positive 1/4. And then I'll do the same thing with c. I've got the minus 1/3. I'm going to multiply that times minus 1. So that gives me c to the 1/3. Okay. So now let's see if we can clean that up a little bit. Okay, so for this first fraction, there's a nice little trick here. You can take this entire expression on the bottom here, this guy right here, see if I can grab that again, there we are, and move it so that instead of being on the bottom, it's on the top. And you can do that as long as you make this exponent positive. And we'll do the same thing with this one. We're going to take this b to the negative 3 power. Let's see if I can grab it. And I'm going to move it. I'm going to put it on the bottom. And I can do that as long as I change the exponent to a positive. So that's a legitimate thing to do with these fractions and negative exponents. Okay, what do I have here? I've got b to the 1/4, and I've got c to the 1/3, and I just have a 1 on the bottom. Okay, so let me make this as a big fraction bar. So c to the 10/3, c to the 1/3, b to the 1/4, and b to the what we had 3 halves. That should be b to the 3 halves. And somehow I lost the 2 when I tried to move it. Yeah, b to the negative 3 halves. Oh, no. It was to the negative 3, wasn't it? Yes, it was. Problem with this idea of moving things around, I lose my previous work. Sorry about that. I hope you have it on paper. Okay, so I've got b cubed on the bottom. B cubed. Okay, adding up the exponents. I've got c to the 11/3 up top, and I'm going to subtract the exponents here. So I got b to the 3, take away a quarter. So this is 12 quarters, take away 1 quarter is 11 quarters. Okay, so let's double check in the back. I'll pause this again. Okay, so we're good there. Typical test problem, probably not, maybe a bonus question. That might be a nice bonus question. As these get down towards the end, I mean, this next one, sort of the same way. Number 85 talks about k to the 1/4, and you're multiplying that times k to the 3 halves. Actually, this problem looks much easier. Minus k to the 1/2. Okay, so think of a similar problem if you had x squared times x cubed minus x to the 1st. You're multiplying in here. So this would be x to the 5th minus x cubed. Remember, you're adding the exponents. So we're going to do the same thing here. We're going to multiply in here, and we're going to add those exponents. So this becomes k to the 1/4 plus 3 halves. We'll have to do that. And then we multiply again, and we get k to the 1/4 plus 1/2. You're always adding the exponents when you multiply, just like down here, right? 2 plus 3 is 5. Okay, so let's see. That 1/2 and 6/4 is, or sorry, 1/4 and 6/4 is 7/4. So we have k to the 7/4. And we're taking away, this is 1/4 and 2/4, it's 3/4. 3/4. K to the 3/4. Okay, and there we are. I don't think there's much more you can do with that. Again, just checking in the back of the book. Okay, and the author does leave it that way. Okay, 3 more problems. These will go, I think, a little bit quickly. We have 91, which is the 5th root of x cubed. And we're multiplying it times the 4th root of x. The directions say write with rational exponents. So this is x to the 3/5. Remember, the roots are on the bottom. Times x to the 1/4. 1/4. And then apply the properties of exponents. Assume all variables represent positive real numbers. Give the answer in exponential form. So they don't want radicals in the end. They want exponents. So this is going to be x to the 3/5 plus 1/4, right? You're adding exponents when you multiply, just like this. A squared times a to the 5th is a to the 7th. So same idea. We're just adding these up. And so what's that? 20, 12, 17, 20. Okay, so that's our final answer. That's number 91. Okay, problem 95, square root of y times the cube root of yz. I'm going to write this one as y to the 1/2 times yz to the 1/3. And then I'm going to make sure that that 1/3 goes with both bits. So we have y to the 1/2 times y to the 1/3 times z to the 1/3. I'm here, when I see this, these two factors raised to the 1/3. The 1/3 has to go to both pieces inside. Okay, so now I can go ahead and just add up the exponents. So I have y to the 5/6 times z to the 1/3, and that's my final answer. Okay, and the last problem in the problem set is a nested radical problem where we have the square root of the square root of the square root of x, right? And we're supposed to make some sense of that. Well, if we start with this is x to the 1/2, right? The little guy right here, this square root of x, is in fact x to the 1/2. But now I'm going to write it as x to the 1/2, and I'm going to raise that to the 1/2. That's going to be, let me color code this. This will be my second radical, will be to the 1/2. And I can deal with that, right? Because when we have one power raised to another power, we multiply the exponents. 1/2 times 1/2 is 1/4. Okay, so that's this becomes this. And then I have to do my last outside radical. So I have this. I've got x to the 1/4. I'm going to raise that to the 1/2. So multiply one more time, which is x to the 1/8. Interesting looking problem. The square root of the square root of the square root of x is the same as the 8th root of x. Okay, practice these, come up with questions when we meet on Tuesday. And again, I'll put another couple little video discussions for 8.3 and 8.4 and 8.5. We'll try to get you through the homework relatively unscathed.